the early Jurassic. Lush forests teeming with life of all shapes and sizes. This is not the Amazon, it's Antarctica, 190 million years ago.
Antarctica today is a very different place than it was in the past.
A team of scientists have traveled to the 160-kilometer-long Shackleton Glacier to uncover this lost prehistoric world.
If we want to really understand what's happening on a global level in Earth history, we have to go all over the place. We have to go to places like Antarctica.
Ancient fossils buried in the rock reveal creatures that went through hell on Earth in order to survive. Including the worst mass extinction in our planet's history.
It's a survivor lineage, one of the few lineages of terrestrial animals that survived the Permian mass extinction event.
Lystrosaurus was able to make it through the worst that the Earth could throw at it.
From the ashes of this great dying, an Earth 2.0 emerges, with a new dominant force slowly coming to the fore. Dinosaurs. But as the continents split, how did they survive the polar conditions? And how did Antarctica transform into the frozen continent we see today? The first dinosaurs appeared around 231 million years ago, during the late Triassic. But their dominance was during the Jurassic period, 50 million years later. In early expeditions to Antarctica, scientists had only found proto-mammals, giant amphibians, and primitive reptiles. In 1986, scientists unknowingly discovered the first dinosaur on an Antarctic island. It would later turn out to be a relative of the club-tailed Ankylosaurus. But the first in-the-field discovery actually happened 4 years later. Antarctic authority Bill Hammer knew immediately it was something special.
We go around this corner, and there's a femur that's about 1 meter long, huge femur, and I'm just looking at it. And David goes, well, what is it? I said, well, I'll tell you one thing, there's got to be a dinosaur. There's nothing from the Mesozoic that big except for dinosaurs.
A theropod, a two-legged carnivore, one of the largest land carnivores of its day. They christened it Cryolophosaurus, meaning frozen crested lizard.
You find a dinosaur, and you have to get an unlisted phone number. And the New York Times is calling, NPR, you know, everybody's calling you. It takes dinosaurs to excite people like that, I guess.
It wasn't just the fact that it was a dinosaur. It bore a superficial similarity to the T-Rex. However, it wasn't related to this iconic carnivore that wouldn't walk the Earth for another 124 million years. It has a very strange feature on its head, a bony plate shaped like a crest that gave it its name. Some dinosaurs had plates for defense. This crest seemed to have no particular function. The Cryolophosaurus was first discovered near the Beardmore Glacier about 170 kilometers away from the Shackleton expedition site. It took many attempts to extract it from frozen rocks. Eventually, after 3 expeditions spanning 20 years of excavation, in 2011, Hammer and his teams would complete the job and remove the remaining pieces of the fossil jigsaw. Both the current co-expedition leaders, Dr. Nate Smith and Dr. Pete Makovicki, were part of that historic dig.
This is Nate Smith from the Field Museum, and back in the Cryolophosaurus quarry, you can see our block is starting to get much more well-defined.
The Cryolophosaurus quarry was a really emotional and amazing time, incredibly exciting, and one of the most monumental parts of my career.
We discovered that we have about 30 bones exposed, and a lot of them appear to be articulated. That is, they're still joined together in the natural way they would have been in the animal. So we have probably somewhere between 1/3 and 1/2 of the animal still in the rock.
Instead of removing the fossilized bones, the team extricate the whole block of rock in which the fossils are embedded. Block by block, they carry the precious rock to the waiting helicopter.
We finally finished the quarry. This quarry was started in 1990-91, so 20 years later, we finally got the last bones out of it. This has been one of the most fantastic experiences of my life. Being in Antarctica is a great experience, but this is probably the greatest experience of Antarctica, even though it was the most difficult.
The discovery of an apex predator, like Cryolophosaurus, begs the question, what did these 2-legged carnivores prey on? They would need a considerable diet of meat to thrive down in the polar forests. From the same fossil area as Cryolophosaurus emerged a candidate, now known as Glacialosaurus.
Glacialosaurus is a dinosaur that I named with Diego Pol in 2007. We know that Glacialosaurus was actually a pretty large animal. It probably was the largest herbivore living in Antarctica during the early Jurassic.
This 7-meter-long, 5-ton plant-eating dinosaur was fleet-footed. As these early Jurassic dinosaurs stormed onto the scene, the ground beneath their feet was also on the move. Earth's supercontinent, Pangaea, split apart to form smaller landmasses, Laurasia and Gondwana. And the ocean that divided the two was the driving force behind this new climate, the Mesozoic Age.
If we kind of roll the time ticker back all the way to the Mesozoic, the age of dinosaurs, Antarctica was still connected to the rest of the southern continents and Gondwana. It was completely ice-free, right? So it was a much warmer climate that these animals and plants could thrive in.
Glacialosaurus needed to be swift, as it was prime beef for Cryolophosaurus. Stalking the lush Jurassic forests of Antarctica, this solo hunter may have targeted Glacialosaurus groups, like big cats stalking savanna herbivores today. For these great carnivores, one long-necked plant eater might feed him and others for days. But you have to catch them first. This 7-meter-long theropod may have run at up to 40 kilometers per hour. But evolution often gives the prey the edge in a foot race like this. Cryolophosaurus won't be able to maintain top speed for long. He'll need some luck. A herd of Glacialosaurus with their backs to the wall makes him think again. Due to its mysterious crest, it is often given the nickname Elvisaurus. But what was it for? Perhaps to attract a mate. Much to the relief of the group, the male has scented one close nearby. Cryolophosaurus may even have had bright colors on their heads to attract mates, like cassowaries do today.
My colleague Pete Makovic actually did a lot of work researching modern birds and their crests and their colorations, and one of the interesting things that he found is that it's often not the crest itself that gets that elaborate coloration, but the skin around the eye, the wattle and the neck, and parts of the face that gets color.
To this day, the Cryolophosaurus has not been found anywhere else on Earth. It probably dominated the early Jurassic period in Antarctica. And as the period wore on, dinosaurs grew larger and larger all over the world, thanks to an explosion of plant life that came with the new global warming. The behemoths of the Jurassic world, the sauropods. There were many different species of these giant herbivores. But even amongst this gargantuan group, there was one species that stood out from everyone.
The kind of zenith of that sauropodomorph dinosaur group are the titanosaurs, which are aptly named because they're some of the largest land animals that ever lived.
The titanosaurs were colossal. 36 meters long, weighing around 60 tons, or a dozen elephants. The adults had no natural predators. Only a natural disaster could stop them.
Titanosaurs are a biological mystery. They're not like anything else that's ever lived on Earth before or since.
These colossal vegetarian beasts dominated the Jurassic and later Cretaceous periods all over the world, except for Antarctica. Or so scientists thought. In 2011, a fossil was unearthed on Antarctica's James Ross Island, revealing these giants of the dinosaur world did indeed visit Earth's southernmost landmass. But how could something longer than a blue whale survive on land?
You would think that those huge body sizes that they obtained would be almost impossible to have on land. You know, they're not like whales floating around in the water, kind of in the absence of gravity. Instead, they're walking on land just like we do. And so sauropods have kind of adapted some interesting characteristics of their anatomy that help them survive in these crazy terrestrial environments. They have these giant columnar limbs, perfectly adapted to bearing their massive body weight so they can walk around on land, just like an elephant. Their spinal columns are so long, they've been called a walking backbone.
Their incredibly long necks were filled with air sacs, like modern birds, to help them breathe more efficiently and to lighten the load of their large skeletons.
At the end of their long necks, they have a tiny little skull with this tiny brain and teeth that are made only for eating plants.
Their several 100-kilogram hearts were the size of a large man. Every heartbeat pumped about 90 liters of blood through its arteries.
So trying to understand how these organisms lived for hundreds of millions of years doing this crazy body plan is one of the biggest mysteries of paleontology.
Maybe titanosaurs competed with each other like today's giraffes. It could have been a brutal competition to see who was the dominant or alpha male. All part and parcel to the difficult detective work paleontologists go through, piecing together evidence that's millions of years old. So these giants thrived all over the world, in the lush tropical forests of the Cretaceous. Evidence was found that, at the very least, Titanosaur may have treated Antarctica as a superhighway. While most early Titanosaur fossils were found in South America, in recent years, a few species have been dragged up from rocks on the other side of the world, in Australia. Fossils similar to their older South American counterparts.
When we look at some of these dinosaurs, like titanosaurs, from, say, Argentina, Antarctica, and Australia, we can see that they were somehow related to one another. It shows that they had a common ancestry from when all of those continents were together in Gondwana.
Their discovery in Australia means that the giant mega dinosaurs had to pound through the polar forests. With ancient Antarctica serving as a land bridge that allowed titanosaurs to get to Australia from South America, where they were abundant.
It makes sense, as the southern continents were still connected during this time, that titanosaurs would have at least been able to travel through Antarctica between these different regions.
In Antarctica, the giant titanosaurs would have discovered a cooler climate, but ice-free and thick with forests, on an epic road trip to Australia. No predator could stop these colossal forces of nature.
Well, being giants are a really good strategy if you want to avoid getting eaten by almost anything. So when you look at modern ecosystems like sub-Saharan Africa, you see elephants really don't have very many natural predators once they get to their adult size. If you can get big, why not get big? It's a really great strategy for avoiding being eaten.
Today's titans, like elephants, could never grow so large because they carry their young to term in a womb. Titanosaurs don't have this limitation. They were egg layers. Herds of females laid thousands of eggs together, up to 40 at one time in their shallow nests. But their young were not so invincible. They were extremely vulnerable to predators.
Where we're probably going to see the highest levels of mortality in animals like titanosaurs is with the hatchlings and the young babies. That's when they're going to be the most vulnerable to predators.
Left to fend for themselves by the adults, these kids needed their own evolutionary lifeline.
When you think about how hard it would be to live life at tiny sizes for a very long time back in the Jurassic or Cretaceous when all of these dinosaurs were running around, it makes a lot of sense that one of their strategies was rapid growth rates. The faster you can get big, the more likely you are to survive.
But trying to calculate how fast these dinosaurs grew from adult specimens is difficult, if not impossible. Until Dr. Rogers stumbled upon some unclassified fossils in 2012.
I was searching through a collection for crocodile and turtle bones, and along the way I kept finding small sauropod bones. And at the end of the day, I realized I had quite a lot of the skeleton, all bones from a single tiny individual sauropod that happened to be the smallest sauropod that we know of outside of an egg. I knew immediately that it was pretty important that we hadn't had any tiny young animal fossils. And so to find those tiny bones, I had an insight about what these little tiny animals looked like. You know, just moving around in a museum collection, opening drawers, there's always something new to be discovered. And I would argue that some of the most important discoveries in paleontology happen because someone takes a different look at something that someone else collected 20 years ago, 100 years ago.
These tiny bones were evidence that titanosaurs had precocial young, meaning their infants are more like tiny adults from hatching.
We think that these baby sauropods were, once they hatched, pretty much ready to run around on their own.
Just how long did it take them to become giants? By magnifying paper-thin cross-sections of her accidental discovery, Dr. Rogers can see the structure of the bones and blood supply and determine how fast they grew.
When you take a look at a thin section of a dinosaur bone like this, you see lots of little circles all over the bone. And those little circles are places where blood vessels used to run in and out of this bone when the animal was alive. The more blood vessels an animal has and the more directions that they go, the faster an animal is growing. Its cells tell us it's growing very, very quickly, and all of the blood vessels all over the bone tell us it's growing quickly as well.
The mortality rate was high for young titanosaurs, but this fast growth rate gave them a fighting chance. By comparison, a human baby doubles in size by 5 months. Titanosaurs double in size after 5 days. By their first birthday, they would shoot from 20 to 1,600 kilos.
This is the femur of a 3-month-old titanosaur, and next to it is the femur of a 20-year-old titanosaur. Taking a look at the difference in sizes of these animals really reveals something about how fast this tiny animal would have had to grow to get that big in just 20 years.
Antarctica's connection to other land masses during this time made it a highway for migration of animals as big as titanosaurs. But Antarctica was different. Although it was a temperate climate and its polar summers were endless, it quickly transformed into a long, dark polar winter.
One of the enduring mysteries of Antarctic paleontology is what these ecosystems and communities were like. These animals are going to experience several months of perpetual sunlight during the summer and several months of prolonged darkness in the winter.
We know that plant life went dormant in this period, and higher carbon dioxide levels helped prehistoric plants and forests to survive the long months with no sun.
They would have shut down with their photosynthesis during the winters, but somehow they survived and they grew in those environments.
But how did prehistoric animals like the dinosaurs survive in the polar darkness? Not only does the sun never pierce the Antarctic gloom for 4 months, the temperature drops to 0 or below freezing.
This is very different from what most of us think of as an ecosystem for dinosaurs. Is dinosaurs living in complete darkness during several months of the winter and sub-freezing temperatures. Did it get warm some days? Sure. But for the most part, it would have been a pretty challenging environment for any animals living there all year round.
In the Transantarctic Mountains, the team continue to seek further evidence for this enigma. The paleobotanists are having a good run of fossil hunting this expedition.
Okay, I heard an "oh, cool" over here.
Yeah,
oh, nice, yeah.
But for the paleontologists, it's always tough work to extract fossils from frozen rock. A possible clue to this polar survival mystery was buried deep in ancient rocks in Antarctica's former neighbor, Australia. During the mid-Cretaceous, around 100 million years ago, Southeast Australia lay in the polar region. Here, a tiny dinosaur may have adapted to the sunless winters in a unique way.
Lielanosaura was a small dinosaur of which bits and pieces were discovered at a place called Dinosaur Cove. It was named after the daughter of Patricia Vickers-Rich and Tom Rich,
Lielanosaura was a turkey-sized herbivorous dinosaur and was likely a permanent resident of the polar forests. Unlike larger dinosaurs, Lielanosaura weren't big enough to walk thousands of kilometers to escape the polar winters, like many animals and birds do today to avoid modern winters.
It was probably too small to migrate. That requires a lot of energy, a lot of food to be able to move thousands of kilometers. And when you have short legs, it's a lot tougher to do that.
In the tiny Lielanosaura fossil, scientists found a potential insight into how dinosaurs evolved to survive the dark polar months.
The skull has large orbits, so those are the eye sockets where the eyes used to be. But toward the back of the skull, the sand filled in the area that would have been its optic lobe. And this looks like it's relatively large in that skull, too. Both of these pieces of evidence then suggest that maybe this Lielanosaura was good at seeing in the dark.
In nocturnal animals, big eyes exploit what little light is available, while enlarged optic lobes can more effectively process the visual information coming in. But the science is far from certain on this one specimen of Lielanosaura.
We know there's a lot of variation in animal proportions, including things like the eyes, and some of that variation is also ontogenetic, which is to say that we know that both in modern birds and dinosaurs, smaller animals tend to have proportionally larger eyes.
Having good night vision would have been important to catch prey, but other strategies would still be needed to cope with living in 4 months of the cold polar darkness. Trace fossil expert Anthony Martin found a possible answer only a few kilometers from the discovery site of Lielanosaura.
I am in Victoria, Australia, at Knowledge Creek, where I'm looking at some of the Cretaceous rocks that are in this area. In that cliffside, I saw this tube-like structure that went down and then it expanded and then it rounded at the end. And I remember having this feeling inside of me with, wait, that looks familiar. A similar structure is above it, filled just with sand, and having also somewhat of a spiral shape. As we go over to the right, we can see that there is yet a third structure, which is similar but a little more collapsed. And that's when I wondered, is this possibly a dinosaur burrow?
Modern animals can use burrows to take refuge from extreme heat, or in other cases, extreme cold. And the 3 burrow structures in Australia were just the right size for a little dinosaur hoping to hide out from a polar winter.
So that made me wonder, okay, well, what kind of animals could have lived in these? And one of the possibilities would have been Laelinosaura or some of the other small ornithischian dinosaurs that lived in that area then.
Creatures could have used this adaptation across the ages in order to survive Antarctica. Even during the most brutal mass extinction in the Earth's history, 250 million years ago. But is there any further evidence in Antarctica? The answer may come from the hardy Lystrosaurus, a mammal-like reptile and survivor of the Great Dying Event that wiped out 90% of animals at the end of the Permian. Back on Shackleton Glacier, Chris Sidor and Megan Whitney are making great headway, preparing a fossil embedded in an unusual way in a small cliff.
This was a Lystrosaurus that was in a totally vertical cliff face.
This is a new territory because I've never done anything into a sheer cliff wall.
Usually that's not where you find fossils. It just happened to be that this one was poking out of the side, and we needed to extract it from this vertical wall. And in order to do that, we needed to basically get around it. We wound up using the roto hammer and putting a bunch of holes in, managed to get a bunch of the rock around it, and we were chiseling and sawing and doing everything else.
Oh yeah, I see the crack. Yep. There it is. Right where we want it to go. Well, that's good. We got the first
piece out?
First piece out, and this one goes right here. That was the easy piece, however. The next piece is going to be a little trickier, I think.
Comparing a variety of Lystrosaurus fossils from polar regions like Antarctica with non-polar regions like South Africa, a startling possibility emerges. A cross-section of their small tusks show variation in their growth rings, the first evidence of how they or any animal might have survived polar winter.
Chris Sidor and Meg Whitney have studied those growth lines very closely in both Antarctic fossils and some of the South African fossils. And what they've discovered is that in the Antarctic fossils, there are kind of periods where you see really closely spaced lines that are kind of correspond to stressful times in the environment when the animal might be slowing down some of its growth. And that's consistent with possibly seasonal torpor, where these animals are experiencing lower metabolic activity, possibly during the Antarctic winters.
We find many Lystrosaurus after this mass extinction that killed 95% of all life living on Earth. We find it survived. I don't think that's a coincidence.
Animals use torpor to this day. At the extreme end is hibernation, a reduction in metabolism, body temperature, and activity lasting weeks. If some form of torpor is evident in the tusks of the mammal ancestor Lystrosaurus, animals may have been using this adaptation to survive Antarctic conditions and even mass extinctions for hundreds of millions of years. Despite the polar nights, life found creative ways to survive, waiting for the good times to return in the long summer months. Over 180 million years after the Great Dying, the dinosaurs continued to dominate our planet. But then, 66 million years ago, a remnant of the solar system came hurtling into the Earth's atmosphere, something even the dinosaurs couldn't adapt to. An asteroid 15 kilometers wide strikes the Yucatan Peninsula in Mexico. The resulting impact contributed greatly to the end of the dinosaurs. The evidence litters the geological record of our planet known as the Cretaceous Tertiary, or KT boundary.
The enriched iridium layer is one of the key pieces of evidence supporting the asteroid impact, that it's found kind of at the same time in multiple areas across the globe.
The dust from the asteroid impact blocked out the sun, leading to an almost total collapse of the ecosystem. 75% of life, including all animals larger than 25 kilograms, died out. Even in the polar region of Antarctica. But what came in their place? The animals that survived the KT extinction are the ancestors of today's reptiles and amphibians, mammals and fish. And a strange type of bird would come to Antarctica. The penguin. With mystery surrounding its bizarre evolution since the first discovery. Inhabiting Antarctica's coastal edges and islands are many species of penguin. But only the emperor and the Adelie live permanently there, feeding in the ocean and nesting on land or sea ice. But where and how did they evolve? And what are their links to the end of the dinosaur era? Could the predecessors to the modern penguin hold clues about what happened in the immediate aftermath of the dinosaurs?
The bird fossil record is notoriously spotty and scarce because most birds have very lightweight skeletons, delicate bones. Penguins are kind of different with thicker bones. We have a much better fossil record from penguins than we do for a lot of other groups of birds.
The first fossil came to light in 1980. Although they didn't know it at the time, it was to become the oldest penguin fossil discovered. It lived 60 to 62 million years ago, not long after the death of the dinosaurs. This specimen, named Waimanu, meaning water bird in Maori, was like a hybrid of a seabird and a modern penguin, and probably resembled a modern-day New Zealand species of bird.
Waimanu is a penguin, but it has a lot of features that look quite similar to some other modern seabird groups like cormorants, also known as shags, that are found throughout the world.
So Waimanu was an early penguin, and was unlikely to have had the ability to fly. Penguins continued to evolve as flightless birds, using their smaller wings to power them through the water.
When you first look at a penguin, it's easy to almost forget that it's a bird. But penguins are indeed a bird. They have a bill, they lay eggs, they have feathers. There's no mistaking when you look at every layer of their physiology and behavior that they are indeed birds.
So the penguin's ancestor was probably like a modern-day ocean hunting bird.
They're closely related to procellariforms, which is the tube-nosed birds, such as petrels, albatrosses, shearwaters. Eventually, you get one of those ancestors that adapts towards staying in the water longer and trying to catch its food by going deeper, swimming longer.
Today, penguins have adapted to ocean predators. By living and nesting on land, they go to the sea only to fish. But evidence has revealed something even more surprising. The fossil record shows that after Waimanu, even bigger versions of penguins were discovered in Antarctica, and several species in New Zealand as well. Some of these giant species were about a third of a meter taller and almost double the weight of our largest penguin today, the emperor. Why did such a large penguin live then and not now? The asteroid that struck our Earth 66 million years ago not only killed land animals, it also wiped out most of the large marine predators, leaving an ecosystem niche open to the evolving penguin.
You have an ocean that's probably empty of a lot of top predators. You have a few seabirds starting to spread around the world and find that there are all of these open niches, open spaces in the environment waiting for a species to evolve to fill that niche and exploit the resources.
We know that with the death of terrestrial dinosaurs, strange new creatures like penguins sprung to life on Antarctica, and the seas began to fill up again with marine life. But Antarctica's and New Zealand's giant penguins and flighted birds have helped stir up the biggest mystery in paleontology today. Are they the true descendants of dinosaurs? Did their lineage, so successful for 165 million years, stop with that catastrophe? Or did something of the dinosaurs survive to this day in the form of birds? The early penguins suggest that their flighted relatives existed before the asteroid struck. We now know that some dinosaurs did have feathers, and they laid eggs like birds. Another clue came in a mysterious hybrid fossil named Archaeopteryx, discovered on the other side of the world.
Archaeopteryx played a big role in establishing that link between dinosaurs and modern birds. Right? It was, clearly a feathered dinosaur, but also still had teeth, still had a long tail, kind of displayed this nice mosaic of features, still retaining a lot of dinosaur anatomy, but also having a lot of those key traits that we find later on in modern birds.
But the 150 million year old Archaeopteryx was just one piece of evidence. Unearthing a much younger fossil would provide a later missing link. A paleontologist working on a small Antarctic island called Vega stumbled upon such a fossil. Like many discoveries, it lay unidentified for 2 decades. But a chance re-examination stunned the scientists. The fossilized skeleton dated to around the time of the asteroid impact. It showed striking traits in common with modern ducks and geese. They called it Vegavis.
You could think of it as an early flighted duck. It's the ancestor, potentially, of ducks and geese.
Most stunning of all, it had the oldest known example of an avian vocal organ, a squawk box similar to that of modern waterfowl.
And it is an early ancestor that has a lot of the features that would then develop into and be recognizable in its later groups, such as the syrinx.
So to have a bird fossil that is that old from the Cretaceous, that's kind of nested pretty well within the bird family tree, suggests that a lot of that deeper bird diversification must be at least as old as the late Cretaceous, if not older.
So some avian dinosaurs survived the KT extinction to become birds, while all the non-avian dinosaurs died out. As creatures like the giant penguins took their place and modern mammals took root, Antarctica remained a forested ecosystem for the next 31 million years. but around 35 million years ago, as the final southern continents drifted farther apart, Antarctica would find itself alone at the bottom of the Earth, with devastating consequences.
The post-end Cretaceous mass extinction Antarctica is a very different place. It's going to witness a lot of geographical and climatic change, right? One of the big things that's kind of continuing on there is, the splitting of the southern continents. We're not talking about kind of flipping a light switch. It's kind of a gradual process. And we get the establishment of a circumpolar current. And that's kind of one of the key things that changes climate in Antarctica and allows for ice sheets to start forming again.
Antarctica is surrounded by high sea levels and cool currents. On land, temperatures plunge. Soon, the winter snowfall fails to melt in spring, and then summer. As the ice sheets returned, land mammals died out in Antarctica. Over millions of years, layers of ice pile up. By 15 million years ago, the frozen continent had returned. Today, the layers are 5 kilometers thick in places. All traces of prehistoric animals are hidden under a blanket of ice, until the early 20th century, when explorers stumble upon fossilized leaves. A century later, and the latest expedition comes to an end. At Shackleton Base Camp, the scientists sort through their finds.
I like this tail. It's so cute.
Crates and crates of fossils embedded in rocks, waiting to be extracted back in the lab. A mammoth cause for celebration after 6 weeks living in one of the most isolated places on Earth. It will be a short hop back to McMurdo, and then the long flight back to New Zealand and beyond. But once they get back in their laboratories, the real work begins.
Here's Cryolophosaurus.
Oh, these dorsals came out really nice.
Unveiling the mysteries of Antarctica's lost dinosaur world.
It's kind of like a second Christmas once you get things back into the museum and the lab and start opening up those jackets and preparing things, and it's like discovering it all over again.
Oh,
Look at
wow.
that.
Wow.
Look at that preservation.
Looks very good.
Yeah.
The last time I saw this guy was 5,000 miles away. Except where the ice was, the preservation's really quite remarkable.
Yeah, the bone surface is great.
We found better specimens, more complete specimens, some things that we think may even be new species.
Antarctica is just a piece of a puzzle for us to understand the development of climate and how it affected the plants and animals through that time. There's still a lot to be discovered, and every place you visit has its own special story.
Antarctica's secrets are gradually being revealed.
The paleontology that comes out of Antarctica is invaluable because it fits a piece in the puzzle in the history of life of what did life do when it was in those polar environments over a very long span of time.
But as humankind continues to explore this frozen wasteland, clearly, this isn't the end of the story for ancient life in Antarctica. With each new discovery, the dinosaurs of the frozen continent are roaring back to life.